Okay, so yesterday we graphed exponential decay. Today we're going to look at how they model in the real world. So, when a real life quantity decreases by a fixed amount each year, we can model it with this equation. Y equals A times 1 minus R to the T. So yeah, the only difference between this and the growth equation for a real world is that instead of adding, we're now subtracting from 1. Well, let's think about it. Let's think, why does that work? Right? What's 1 as a percentage? Well, you would just move the decimal over twice. That's 100%, right? Like, this 1 is 100%. So if you're subtracting a certain percentage away, you would have less than 100% left. Right? So let's label what all of our variables stand for. A is still the initial amount. T is still time. R is going to be our percent decrease. And then this 1 minus R, all of this together, okay, this is your decay factor. So let's think about this for a second. If I told you that the percent decrease was 28%, okay? So if my percent decrease was 28%, what would be my decay factor? So the decay factor is 1 minus 0.28, right? Which would be 0.72. Okay, so that means that 72% remains. So whenever we're talking about decay, this number inside that's being raised to the t, it's the amount that remains each year. Okay? A new television costs $1,200. The value of the television decreases by 21% each year. Write an exponential decay model giving the television's value y in dollars after t years. So let's stop there. Whenever we're talking about a model, okay, that's whenever I still have to leave a variable in the equation. So we don't know which year we're doing this for. It's just for any year t, come up with an equation. So I know that it needs to go off of y equals a times 1 minus r to the t. All right, well, what's a? A is that initial amount. That's how much the TV was originally worth. So y equals 1,200. Now it loses 21% each year, right? So as a decimal, that's minus 0.21 to the t. So how much of the TV's cost remains after each year? 1 minus 0.21 is 0.79. So 79% remains every year. So this is my model. Next, it asks us to estimate the value after 2 years. So to estimate the value, if I have this model that will tell me, all I have to do is plug in a 2 for t. 2 for t, t for 2, right in there. Okay, so y equals 1,200.79 squared. So reminder to do 0.79 squared before multiplying by 1,200. So after 2 years, we can say that this TV is going to be worth about $748.92. All right. The last thing that we're going to do is use the graph to estimate when the value will be 300. So we have to graph it first. Oh, yeah, graph the model. So there are a lot of ways that we can approach graphing this. Okay? If we wanted to just make a table, we could just for 1 through 9, but that might take a little while. We could just think about it as like how we have been, right? Like we've been doing the whole 0, 1, 1b. And what's the base of the exponent? The base of the exponent is 0.79. It's what's being raised to that t. So 0.79. And then with this number out in the front, what do you do with your y values? You multiply them by 1200. So 0, 1200, 1, and then 0.79 times 1200 is 900 something. 948. Okay, so that was a good way of getting 2 points, right? Let's try to think about it in another way. If you were to just plug in 0 for t, anything to the 0 power is 1. And just think about it in the sense of after 0 years, right? How much was the TV worth? After 0 time has passed, it's worth the full $1,200, right? So we know that we have the point 0, 1200. So logically it makes sense. Over here doing the 0, 1, 1b, we get the same answer. Okay? After 1 year, 79% of the 1200 remains. Well, guess what 79% times 1200 is? 948. 948. Now, let's just get some more points. After 2 years, what's the value? Well, we just found that on the previous page, right? So 748.92. So whenever we label our axes, it's good to go ahead and label your points too. It's like, okay, this is time, and this is value. So I also want to get a point as far to the right as possible. Okay, the last one that I labeled here is 9. So let's go ahead and find that point. 9. How do you find that point?
0.79 to the 9th.
You raise 0.79 to the 9th power, and then multiply that by 1200. So after 9 years, the TV is worth $143 and how many cents?
82.
And 82 cents. So now I've got enough points to draw a curve and estimate what it'll be worth after 300. Or when it will be worth $300. So 0, 1200, 1, 948, 2, 748, and after 9 I'm down here at 143. Alright, so I'm going to draw a smooth curve through those. Where's the asymptote here? It's at 0. Why is the asymptote at 0? Because there's no k, right? Like, since there's no k, it's never 0. And if you're always taking a certain percentage of something, it won't get past that 0 since we didn't shift down at all. So now, I'm going to use this to estimate when the TV will be worth $300. So I go to $300, and I connect that to my graph. And now all of ours might be a little bit different, okay? And then whenever I follow that down to the x-axis, that's between 6 and 7 years. So when will it be worth 300?
6 to 7 years.
6 to 7 years. And that's how we'll do the decay in a real life situation.